Dropped package. An airplane flies at a constant horizontal speed of 185 meters per second. When the plane is 1420 meters above the ground level, a pilot drops a package of relief supplies for hikers who are isolated by a snowstorm. You really don't care about that part. We're just interested in the numbers, right? So how long will it take the package to reach the ground? How far horizontally will the package fly before it strikes the ground? What is the velocity of the package just before it strikes the ground? And compare the magnitudes of the velocity of the package and the velocity of an object that is dropped from a mountain of the same height as the airplane when they strike the ground. How long will it take the package to reach the ground? We're going to use the second kinematics equation in the y direction, and here it is. Our final height will be 0, that's the ground. 1420 is our initial height. Now we have no velocity in the y direction, no initial velocity in the y direction, just in the x direction. So we have 0 here. Here's our acceleration, it's a negative 9.8. We have 4.9 t squared equals 1420, and we'll take the positive root here to match the physical configuration, 17 seconds. How far horizontally will the package fly? Now we use the second kinematics equation again, but this time in the x direction, and we found the time in part A. So here's the full equation in the x direction, but we're going to start our problem at x0 equals 0, so that goes out. We do have an initial velocity in the x direction, that's the velocity of the plane, but there's no acceleration in the x direction, just in the y direction due to gravity. We put in our initial velocity, and here's our time before it hits the ground, and we find the package goes 3,150 meters. What is the velocity of the package just before it strikes the ground? Now we're going to use the first kinematics equation, which is v is equal to v0 plus at, and we're going to solve independently for the x and y components. I show the x equation here, but what you should know anyway is the velocity stays the same. We're ignoring friction on this to make the problem solvable at this level. So it'll have an x velocity of 185 meters per second. The y velocity, you start with 0, but then gravity accelerates the package, so it has a negative 167 meters per second. That means it's heading in the down direction. To find the magnitude, we use Pythagoras, and we get 249 meters per second. And then to find the angle, we use the inverse tan, and we get negative 42.1 degrees with respect to the x-axis. So that means, if here's a coordinate system, it shows the package striking the ground at this angle here. That's 42.1 degrees, or negative 42.1 degrees. We're now comparing the magnitudes of, here's the plane. It dropped the package, right? Came out like this, but by the time it hit the ground, it hit it at an angle like this. And if I just have a mountain at the same height and I drop the package, well, what's the difference there? The plane gives it a pretty substantial velocity in the x direction, where from the mountain there is no x direction velocity, it's just the y direction. So when we did the math, the plane gave us 249 meters per second. But if we just drop it, all we have is the 1/2 at squared term, and we find the velocity from the mountain is only 167. And the difference is, of course, as we showed in our little pictures here, the contribution of the x velocity of the plane package on its total velocity.